All right, welcome to the final video for our Unit 2A review. Let's take a look at number 19 that asks you to find all solutions for this absolute value equation. Well, the first thing we'll want to do is get the absolute value symbol isolated. Since it's being multiplied by -2, we'll want to divide both sides by -2. All right, -2's cancel on the left, and we get the absolute value of 3x plus 1 is equal to -3. Okay, now at this point, I hope you stop and think for a minute. Do you think there's any x value that I could multiply by 3, add 1 to, then take the absolute value of and get a -3? Well, I don't think so. Let's just remember what this function would look like. Let's see, it would be, well, let's look at the parent function. The parent function looks like this, right? Isn't the output of an absolute value function that hasn't been shifted up or down, which this one wouldn't be, wouldn't the output always be non-negative? Okay, so there's never going to be an x that I can multiply by 3, add 1 to, take the absolute value of, and get an answer or an output of -3. That can't happen. So at this point, you can stop your work and just simply say there is no solution because the output cannot be negative. All right, no solution. Okay, let's move on to number 20, which is an absolute value inequality. It says find the solution set and graph the solution set on a number line. So taking a look at our absolute value inequality, we have the absolute value of 7 plus 2x is less than or equal to 13. So let's draw a number line just to kind of think about this. Okay, so this is not our solution set. This is just a thinking number line. So I'm going to put 0 on my number line. I'm going to put oops. Let me fix that real quick. I'm going to put -13 on my number line and +13 on my number line. And let's think about, again, what absolute value means. Absolute value is a number's distance from 0. So I have an expression whose value is 13 or fewer, 13 or less units from 0. So that would include 13 and -13 because of this equal sign. So I'm going to put a closed circle on -13, a closed circle on +13, and then shade in all the places on the number line that would be less than 13 units from 0. That would be this whole middle part. Okay. Then above what I've shaded in, I'm going to take what's inside the absolute value symbol and write it above what I just shaded in. So 7 plus 2x. All right, so you can take a look at this and see that we're going to have to write a conjunction. Okay, remember less than. Okay, I'm going to write an and statement. And I have a choice here. I can either write an and statement, or since this is a conjunction, I can write a compound inequality. I'm going to write it that way first, and then I'll show you the other way to write your conjunction if you want to write it as two separate inequalities joined by the word and. But if you look at this, okay, look where 7 plus 2x is, okay? It lies at the same time to the right of -13 and to the left of +13. So I could write this as one compound inequality and say -13 is less than or equal to 7 plus 2x, which at the same time is less than or equal to +13. All right, now, if I'm going to solve this compound inequality, I'm going to solve it for x. So my goal is to get this x completely by itself. The first thing I'm going to do is subtract 7. Now let's think about this. If I have 3 expressions lined up, left to right, smallest to largest, if I subtract 7 from all 3 parts, then isn't this compound inequality still going to be true? Okay, the smallest will still be on the left and the biggest will still be on the right by subtracting 7 from all 3 parts. So let's see, -13 minus 7 more would be -20, which is less than or equal to 2x, which at the same time is less than or equal to 13 minus 7 is 6. All right, then we still want to get the x by itself. It's being multiplied by 2, so we're going to divide everything by 2, all 3 parts of the compound inequality. So we end up with -10 is less than or equal to x, which at the same time is less than or equal to +3. All right, So this compound inequality represents our solution set. Okay, and we're also asked to graph the solution set on a number line. So I'm going to draw a number line. Okay, indicate -10 on my number line, indicate +3 on my number line. Now I want, because of these less equal to symbols, I'm going to put a closed circle on -10, a closed circle on 3, and then shade in everything in between. So our solution set would be all numbers from -10 to +3, including -10 and +3. Okay, now, if you don't like writing a compound inequality, let me show you how we could have done the same, gotten the same solution by writing a conjunction joined by the word, which would be two inequalities joined by the word and. So again, let's look back at our thinking number line here. And it's a picture of exactly what we're going to write. We have this 7 plus 2x that is at the same time to the right of -13. So we would say 7 plus 2x is greater than or equal to -13, and at the same time look at 7 plus 2x that lies to the left of +13. So we would say 7 plus 2x is less than or equal to +13. All right, I'm going to pause the video. I think you guys can work out these inequalities on your own. Let me do that and you can check your answer in just a second. All right, so if you prefer to write a conjunction, two inequalities joined by the word and solve each one separately, you'll see that you'll get the same solution set. All x's that are at the same time greater than or equal to -10 and less than or equal to 3. The same thing that you see on this solution number line right here. All right, last one. Let's take a look at number 21. It's an absolute value inequality that involves a greater than symbol, great or, so you should be thinking disjunction. So let's start by sketching a thinking number line. Okay, we're talking about the absolute value of something that's greater than 17, a distance from 0 greater than 17. So let's talk about where that happens on the number line. I'm going to put -17 on the number line and +17 on the number line. Now, where are we more than 17 units or greater than 17 units away from 0? That would be on the outsides of the number line. Now, I'm going to put open circles on -17 and +17 because of the strictly greater than symbol. And then I'm going to shade everything to the left of -17. And I'm going to shade everything to the right of +17 because those are the areas of the number line that are greater than or more than 17 units from 0. Okay, then if you would, take what's inside your absolute value symbol, and I want you to write it above anywhere you've shaded in. So we're going to write 5x plus 2 over this part of the number line, and 5x, oh, did I say plus 2? I'm sorry, I meant minus 2. And then 5x minus 2 over this part. And now you can see that we're clearly how to write your two inequalities joined by the word or. Okay, over here, 5x minus 2 is lying to the left of -17. To the left of means less than. So 5x minus 2 is less than -17, or look over here, 5x minus 2 is lying to the right of +17, so that would be greater than +17. Greater than means lies to the right of. All right, I'm going to go ahead and pause this video and solve these two inequalities, and then I'll click it back on to sketch the number line solution. All right, so when you solve these two inequalities, your solution set looks like this. X is less than or equal to negative, whoops, sorry about that, let me fix that. Not less than or equal to, it's strictly less than. Okay, let me fix that. All right, x is less than -3, or x is greater than 19/5, which is 3 4/5. So on our number line, our solution number line that represents our solution set, we're going to put an open circle on -3, and then shade everything that lies to the left of -3. and then an open circle on positive 19/5 and shade everything that lies to the right. All right, so that brings us to the end of our Unit 2A review. Please let me know if this video has been helpful, and if you have any further questions, be sure and ask me in class.